Now let's apply this to an organic problem. So let's calculate the percent yield of a bromination reaction. You'll learn later bromination requires a double bond. And we need our balanced equation. This one's pretty easy to balance. Our stoichiometry here is all 1-to-1. It takes 1 mole of this to produce a product, or 1 mole of our product, 1 mole of the bromine to produce 1 mole of our product. Okay. Now, our reaction reads that we're starting with 1.5 millimoles of the 2-butene. Okay. We are adding bromine to this reaction so that a yellow color persists. Now, you will learn this more in lab, but when you add bromine to the solution, as long as there's bromine around, you're going to have a slight yellow color because the bromine is very colored. Okay? So it tells me, as long as I have a yellow color persisting, I have bromine in that solution. That means this has to be excess. We don't really know what it is. We're adding it dropwise. But it's in excess. Okay. That tells us automatically this is our limiting reagent. Okay. Now, there's a little less math required on this side because we already have a millimolar amount of our limiting reagent. Big B for the butene. We have a 1-to-1 molar ratio. So, since we have a 1-to-1 molar ratio of 2-butene to our product, now we're going to take the molar amount of our product and convert that to grams. That's going to require us to know the molar mass of our product. Okay. When you add that up, it is a molar mass of 215.8 grams per mole. Now, this is in millimoles. Okay. This is in grams per mole, and we want our units to match. So you have to do a little bit of conversion, but when you go through this conversion, you'll find that to convert grams per mole to milligrams per millimole, you change both of those units by the same factor, so it's the same number. Don't let that confuse you. Actually work the math out and prove to yourself that grams per mole is the same as milligrams per millimole. So you can go through those conversions yourself. When we do this math, this is product. We get a theoretical yield of 323.7 milligrams. Okay. Actually, these should be millimoles. But it's a 1-to-1 molar ratio, so it's going to be fine. Theoretical yield of 323.7 milligrams. We isolated in lab 257 milligrams. So since we isolated that and we weighed that out, that's our actual yield, theoretical. Percent yield is going to be actual divided by theoretical times 100. Doing this math is going to give us 79.4% yield. So here are two problems presented on percent yield. One was from general chemistry, the other was from organic. Both worked the same way.